The titration of benzoic acid with sodium hydroxide is a 1-to-1 molar ratio. So at the equivalence point of the titration, the moles of benzoic acid will equal the moles of sodium hydroxide. Let's use the information given in the problem to calculate the moles of benzoic acid. We have 0.415 molar benzoic acid times the volume, 21.4 milliliters in liters, gives us 8.88 times 10 to the minus 3 moles of benzoic acid. I'm going to put that in my reaction chart. At the equivalence point, we have the same number of moles of the sodium hydroxide. Both the acid and the base will be used up in the reaction. And we will produce 8.88 times 10 to the minus 3 moles of the sodium benzoate. In order to determine the pH of the salt solution, we have to determine the concentration of the salt. We will need the total volume of acid and base, and since we already know the volume of the benzoic acid, we can calculate the volume of the sodium hydroxide. We know that we've added 8.88 times 10 to the minus 3 moles of the sodium hydroxide, and that our sodium hydroxide is 0.363 molar. That will give us 0.0245 liters of sodium hydroxide added. Total volume will equal the liters of acid plus liters of base, and total volume will equal 0.0459 liters. To find the concentration of the salt, we divide the moles of sodium benzoate by the volume, and we get 0.193 molar sodium benzoate solution. Now we have to find the pH of the salt produced during the titration. So the sodium benzoate will dissolve or dissociate 100% to produce sodium ions and benzoate ions. And we have water that will self-ionize into hydronium and hydroxide ions. The conjugate base of the weak acid will react with the hydronium ions produced by water in a hydrolysis reaction to reform benzoic acid and hydroxide ions. We need the Kb equation. Kb equals concentration of benzoic acid times the concentration of OH minus over the concentration of benzoate. And we will also need to calculate the Kb of benzoate, the conjugate base of benzoic acid, using the Ka. Kw equals Ka times Kb, where Kw is the ion product of water, which we will divide by the value of Ka given. And our Kb is equal to 1.6 times 10 to the minus 10. Let's set up our ice chart. The initial concentration of the salt we calculated earlier as 0.193 molar. The reaction can only proceed in the forward direction, and concentrations at equilibrium are I plus C. Let's solve for x using the Kb equation. 1.6 times 10 to the minus 10 equals x squared divided by 0.193. Note that I've already assumed that x is small and disregarded it in the denominator. If I solve for x, we get 5.6 times 10 to the minus 6. X is the concentration of OH minus, and so we must find the POH first by taking the negative log of 5.6 times 10 to the minus 6 equals 5.25, and a pH will equal 14 minus 5.25, which equals 8.75.